Okay, we are bottom of the curve, and our problem is number 2 off of the 2014 AP test. This is a calculator aloud problem, so be sure to keep it on hand while doing this, as it'll be extremely important in getting it correct. So the problem provides the graph of R, and the problem reads, let R be the region enclosed by the graph of f of x equals x squared minus 2.3x plus 4, as well as the horizontal line y equals 4, as shown in the figure above. There are 3 parts in this problem, A, B, and C.
For part A, we have to find the area of the solid generated when we rotate the region R around the horizontal line y is equal to -2. For reference, the region R is bounded by the 2 functions y is equal to 4 and y is equal to x to the 4th minus 2.3x cubed plus 4. These 2 functions intersect at the x values of 0 and 2.3. These are important because these become the upper and lower bounds of our integral. To set up our integral, we use the washer method. Outside the integral is pi, and inside the integral is the upper function in relation to our axis of rotation, which in this case is y is equal to 4, minus -2 to represent that there is an extra distance beyond just going to the y-axis because of our axis of rotation being lower than the y-axis, squared, minus the upper function, x to the 4th, minus 2.3x cubed, plus 4, again minus -2 to represent that extra distance added by having a lower axis of rotation, squared, and subtract those 2 squares. Make sure to add dx because notation is important. Thankfully, we can throw all this mess into our calculator, and we get that the volume is equal to 98.868 units cubed. In this problem, 2 points are awarded for setting up your integral correctly, which means that the majority of the points for this problem are awarded for setting up your integral. This is very important. Only a single point is awarded for the correct answer, and 1 more point is awarded for having the correct upper and lower bounds for your integral. Subtracting the volume of a smaller cylinder on the inside from that of a larger cylinder. A good way of visualizing this is by writing your integral as 2 different integrals. The first integral gives you the volume of the solid formed when rotating your upper function around your axis of rotation. To get the volume of the solid so that it doesn't include the area beneath your lower function, the second integral, which calculates the volume of the solid formed by your lower function, is subtracted from the first one.
Region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in the region R. We want to determine the volume of the solid. First, we recognize that the area of each cross-section is equal to 1/2 r squared. Therefore, the integral from 0 to 2.3 of 4 minus the function squared with respect to x will yield the volume. We can plug this into our calculator to get a final answer of 3.574 cubic units. This part of the problem is worth 3 points, 2 for the integrand and 1 for the answer.
Divides R into 2 regions with equal areas. Write, but do not solve, an equation involving integral expressions whose solution gives the value k. So this is a pretty easy problem if you can get your head wrapped around it. Firstly, you know that k is an x value somewhere in R, so therefore it's a value somewhere between 0 and 2.3. 0 and 2.3 are simply the lower and upper limits of the integral which gives r's area. Then, from there, you can write two separate integrals involving this concept and then set them equal to each other. So, since k splits up r, the sum of the integrals must equal r. Thus, you get the integral of r's area given by 4 minus f of x from 0 to k, and the integral of the exact same area, but except this time, limits are from k to 2.3. The problem is worth a total of 2 points. One for the area of r within an integral, and then one for simply writing the equation itself. The basic concept of this problem is simply being able to recognize the various properties of integrals and its relationship with area. So, dividing up an area and then adding the respective parts together naturally give the original area. So, the big thing you need to be able to recognize in this problem to solve it is that the two integrals which give the area equal each other, but also as a sum equal the original r's area.
Student response to part A of this question. This student got 4 out of 4 points. As you can see, they properly set up their integral, adding 2 to both their upper and lower functions and squaring them and taking the difference of those squares. They used their calculator in order to find the final answer, and they got their upper and lower limits of their integral correct. Here is another example of full points on a sample response. This student got 2 points for the correct integrand and 1 point for their correct answer. In this third sample response, the student received 0 points for their work. The sad thing is that if they had simply put a k instead of a 0 as the lower limit of the integral on the right side of their equation, they would have gotten full credit. But unfortunately they did not. There are a few common mistakes that many people make when doing this FRQ. The first of these is setting up their integral wrong in part A. It's good to remember that on the inside your integral should be your outer function squared minus your inner function squared. A mistake that I commonly make is doing my outer function minus my inner function squared, which will give you a wrong answer. Also, it's good to remember that part A is around y equals -2 instead of the x-axis or the y-axis. This really changes how you do the problem. Also, the area of an isosceles right triangle is equal to 1/2 r squared, where r is the length of the smallest leg of an isosceles triangle. Drawing pictures of this really helps visualize it. For part C, visualizing that a line could split an integral in two parts that are exactly equal in area is really helpful. Don't oversimplify it. You can leave it in the unsimplified form because errors in arithmetic can lose you a lot of points in this section. From all of us here at Bottom of the Curve, we wish you good luck on the AP Calculus exam.
Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed. She was looking kind of dumb with her finger and her thumb in the shape of an L on her forehead. Well, the years start coming and they don't stop coming. Fed to the rules and I hit the ground